Now you have to see here. Once we'll press continue in the ANOVA. So you will have one descriptive column, other is the test of homogeneity of variances, and the third one is ANOVA. So look, first of all, in the descriptive statistics, you have to see that what was the mean, what was the standard deviation, and which group is showing highest mean. So here we are having high protein feeds is having higher weight, and low protein feeds are having lower weight. Then the second thing is you have to see the tests of homogeneity of variances. This tests if the assumptions of equal variances across the group is met or not. So if you remember the independent sample t-test, there was also first of all Levene's test. Here again there is a Levene's test, and it is in across all mean, median, modes and all values it is showing greater than 0.05. So if the Levene's test of variances show greater than 0.05 value, so what it means that equal variances assumption is approved. And once equal assumptions are approved, so then you can apply ANOVA test and you can also apply Tucky's test. So here if you see that all the values are greater than 0.05, so now you have got that leverage to apply the ANOVA test. Now you can report this significant value. So now it is significant value. Now you can say that there is differences between the groups, and after reporting this, you can now go towards the Tucky test and now apply the Tucky's test. So look, here is a post hoc test, and it can only be like it will only show in the SPSS description if you just click or you check the Tucky's test. Okay. So here one more thing which is important is that Welch test. So what is happening in the Welch test, that if, for example, if you see here in the slide, if in the test of homogeneity of variances, you had less than 0.05, you had statistically significant results. So what it meant that variances are not equal among the groups. Then you have to use this Welch test instead of this ANOVA test. So if it is greater than 0.05, so you have to report this p-value. If it is less than 0.05, you have to report this p-value. So this is very important while you are just writing your thesis or research publication, that which p-value you have to use. So what Tucky's test has done, that it has created multiple relationships among high protein diet versus low and versus medium. So if you see here that high protein diet when was compared with medium and low protein diet was statistically significant, but here look, only among the relationships among medium and low protein and medium, there is not statistically significant differences. So what it means that high protein diet is a separate group, and you can say that medium and low protein diets are lying among the same spectrum or the groups. So then the next test is the homogeneous subsets, which will come while you are just checking all those boxes in the ANOVA. So look, it is showing you significance value, and it is also showing you that medium and low protein are lying almost in the same spectrum, and the high protein diet is lying completely different in different place. So here the significance values, you don't have to see this, you have to only see that whether these values are lying close towards each other or there is a significant difference. So what Tucky has done, Tucky has spotted the differences. It has spotted the differences that there was no differences between medium and low group, but there were differences between high protein and low and medium protein group. But the homogeneous subsets, what it is doing, that it is bringing close together that which 2 or 3 or 4 groups are having values closer to each other, and then it generates a plot. So this plot is very important when you are seeing the post hoc analysis. So again, what p-value was saying, that high protein diet is statistically significant than medium and low protein diet, and low protein diet and medium protein diet are almost lying on the same spectrum. So this mean plot is also showing this thing. One more thing. So again, for graphs, you have to go to legacy, bar, simple. So these all hacks you will learn when I will give you this PowerPoint presentation. So here you can see that there are differences between the groups, and medium and low group are almost lying at the same level. So one more thing we can do instead of applying post hoc analysis is that when you are just comparing means of three groups, so one more thing you can do. Instead of applying post hoc test, and if you want that you don't have to go towards this complexity, so what you can do is that you can apply independent sample t-test among high protein and medium, medium and low, low and high, low and medium. So in that way, you can also generate a p-value, just like we have studied before that what was happening in the independent sample t-tests. So you can also apply independent sample t-test if you are not willing to apply these sticky test or you find it very confusing. So you can apply independent sample t-test among these groups. So now we are coming towards non-parametric
سلام
tests.
سلام دکتر صاحب اکسیر خوب هستین و خیر سرتان خوب است انشاءالله که بخیر باشین میبخشین دکتر صاحب که پیام آمده بود من دیدم باز تم جواب میتونم صبح که رفتم دیگه پیشتر آمدم.
So non-parametric tests. So first of all, we have got Mann-Whitney tests. Then we will have Wilcoxon signed rank test, and then we will have Pascal-Wallis test. So just like independent sample t-test, it is a non-parametric variant of t-test. So if your data is not normally distributed, so you will apply Mann-Whitney test if assumptions of independent sample t-test are met, but the data is not normal. But the point which I want to highlight is in the all non-parametric tests, what you are doing is that you are creating rank sums rather than the true mean. So you are not actually seeing the differences among the means, you are seeing rank sums. So for example, look, if there are two groups, male and female, and you came to know that the reaction time is not normally distributed. So you will start assigning rank values. First of all, the lowest value is given 1, then subsequently second value, third, fourth, fifth, and sixth, and so on. Then you will have to calculate these rank sums, and then you have to compare these rank sums among each other. So you are not comparing the true mean or median, you are just comparing the rank sums in all the non-parametric tests. So the significance of taking rank sums rather than the differences, the mean is that the data need not to be normally distributed. So if your data is not normally distributed, there are extreme values in your data. So for example, if it is not normally distributed and the data is like this, so you may have 100, 99, but rest of all values are lying around 50. So if you are adding 50 plus 90 plus 100 in the non-parametric or in non-normally distribution, so your mean median mode can get disturbed. So once it can get disturbed, So what will happen that you can't compare groups with each other accurately. So what you are doing is that you are giving rank orders to all of this. So for example, if this was the last one and you have given him rank of 50 starting from 1. So this 99 will be 51 and this 100 will be 52. So what you are doing is that you are closing the gap by giving them a rank number, and in that way you are just comparing the ranks among each other, and that's the only thing which you have to see when you are reporting the data, that whether you have to report mean or whether you have to report ranks. So in all non-parametric tests you have to report ranks. So for non-parametric tests, go towards analyze, non-parametric, legacy dialogues, and two independent samples. So open the same independent samples t-test sheet and just see the legacy dialogues and two independent samples. Now here in the test variable, you have to place the numerical number, and in the grouping variable, you have to place the categorical data. And look here, the test type is already clicked, that is man-Whitney. And again, you have to give the grouping numbers 1 and 2. So in this way, you will get this descriptive ranks and test statistics of man-Whitney tests. So first, again, it will show you this descriptives. Second is showing you ranks. And third is showing you man-Whitney U, Wilcoxon W, asymptomatic significance two-tailed, and then exact significance. So look which value of P you will have to use. So out of this whole slide, what is important is that there are two P values. One is asymptomatic significance two-tailed, another is exact significance. So for exact significance, if your sample size is small, less than 30 or less than 10, you have to use this asymptomatic significance, exact significance. But when your sample size is large, you can use asymptomatic significance. And rest of the values you can easily read, and you can just um, write it down in the interpretation as well. So while you are interpreting, you have to give a comment about descriptive statistics. You have to give a comment about ranks as well, because if you are applying man-Whitney and you are not giving a comment in interpretation about the ranks, so definitely it is like you have to display that in your data interpretation. And then which p-value you have to use, I've told you that you have to use exact significance when you have got small sample, and asymptomatic p-value when you have got large sample. Then the Wilcoxon signed rank test, it's again just like the paired sample t-test. Again, ranking will be done. And then you have to go analyze non-parametric related samples. So here in the non-parametric tests, you have got two different options. Either you have to go to the legacy dialogues, or you just go towards this one sample or independent samples or related samples. So for man-Whitney, you have to go for independent samples. For Wilcoxon, you go for related samples. So in that way, you have to see objective fields, just place blood pressure before and after. So if you choose it, choose this uh, automatically choose the test based on the data. So SPSS on its own will work around and it will apply Wilcoxon signed rank test. But if you want to customize, you can also do that. And if you want to leave it on SPSS, SPSS knows how to apply Wilcoxon test. It will automatically select Wilcoxon test. So this is how you will see Wilcoxon test will be presented. So here, look, the decision is also given that reject the null hypothesis. It means there are differences between the groups. And then these are some of the values which you have to see, but here there is only one p-value. So it means that the difference, whatever the difference was, it was statistically significant. And this graph is very important for Wilcoxon sign rank test, in which it is showing that what's the frequency and what was the blood pressure before and after. And almost all interventions had shown decrease in blood pressure as compared to the before. And this histogram is just to check the normality. So again, that's the old concept which we have discussed. So again, you can go towards related samples, or you can go to the legacy dialogues and you have to see two related samples. So you will have this sort of bar which will open, and here you can choose different tests, BP before, BP after. So this interpretation is given. So again, you have to go for descriptive, you have to go for ranks, and you have to see the Z-score as well. So it's a negative number, so it means that there is a consistent decrease in all the values of the blood pressure, and there is only one p-value, so it will not be difficult for you to interpret. So it is statistically significant. And then now finally, we are having this Kruskal-Wallis test. So it's a non-parametric counterpart to the one-way ANOVA. Again, data do not have to be normally distributed. And again, it will check the ranks differences rather than the true means. So again, look here, that is there is a what analysis of variance or ANOVA is showing you, that it is showing you the differences among the means of the group. And what Kruskal-Wallis is showing you the differences among ranks. So these are two different things. So in ANOVA, you will always, when you are writing and when you are interpreting the data, you will always write differences among the means. But in the Kruskal-Wallis test, you have to give comments about ranks as well. Go towards analyze non-parametric independent samples. In groups, just go for feeds and test fields weight. You can again automatically choose the test based on the data, because when you will do that, SPSS, by seeing the data, SPSS can apply Kruskal-Wallis test. But if you want to be very exact, you can go towards customize Kruskal-Wallis one-way ANOVA. But here in the multiple comparison, you have to see this all pairwise distributions, because the post hoc test, just like in Turkey's test, in non-parametric Kruskal-Wallis test, you usually have no option of any post hoc test. So you will have to see all pairwise comparisons. And that is basically the post hoc test of the Kruskal-Wallis. When you are doing all pairwise, you are checking this. For example, you will click here and you will just check this all pairwise. So here, look, in the start, it will give you the null hypothesis, alternative hypothesis, and it is showing you that reject the null hypothesis. So it means there are differences between the groups. So it means that at least one of the group is different among each other. So this is a diagram or graphical representation which non-parametric tests have on their own. Unlike in parametric tests, you had to go towards graphs and you had to create it on your own. In non-parametric tests, you can find these as well. So these three groups are different. Again, not normally distributed, because you have to see this median line. Median line is not lying at the exact center. So when it will have pairwise comparison of the feeds, so this is basically the post hoc test, and it is also known as Bonferroni corrections for multiple tests. So it is giving you these p-values, adjusted p-values, at which groups are different among each other. So here again, you will see that medium diet and high protein diet is different, but medium diet and low protein diet are not different. So here you don't have to see the significance value, you have to see the adjusted significance level, because you are applying Bonferroni corrections, and which is basically a post hoc test for the Kruskal-Wallis test. So when you will click pairwise comparison of the feeds, you will see that there are three different groups, and high protein diet is lying completely separate to each other, but low protein and medium protein are lying on the same axis. So it means that high protein diet is statistically significant from both medium and Low protein, medium protein is also statistically significant from high protein, and low protein diet is also statistically significant from high protein diet. But in between medium protein diet and low protein diet, there is no statistically significant difference. So this is again showing you that whether the data is normally distributed or non-normal, and it is showing you categorical data information. So again, go towards non-parametric legacy dialogues. K independent samples means Kruskal-Wallis independent samples. In the groupings, you have to write 1 to 3. Why? Because we have assigned high protein diet as 1, medium protein diet as 2, and low protein diet as 3. If you can see the variable view. So write these values, go towards asymptomatic and click continue, click descriptive. So now if you see that previous dialog box in which we had run the test, it didn't show us ranking, but now we have got ranks as well. Okay. So again, non-parametric test, you have to give a comment about the ranks along with this mean. And in this way, finally, you will get this value of the P, which is similar to F value in the ANOVA. And it will tell you how these groups are different based upon ranks. So this is all from my side. I will share these slides with you as well. And this is my contact information. And feel free to join the WhatsApp group, or you can email me, or you can join this WhatsApp group or YouTube or Instagram page as well. So thank you very much for joining. I will end the session.